So now we're going to talk about reflections, and we have two types of reflections. It can reflect about the x-axis, which looks like this. You have a function then, a function g of x, and if it's reflecting about the x-axis, then what you're doing is you're changing the output. You're getting the opposite of your outputs. So if you had an output of 4 in the original function, you're getting an output of -4 in the transformed function. So this is a reflection, reflects about the x-axis. And then the other type of reflection is if you have f of the opposite of x. So in other words, you're changing the sign on the input, but getting then an output, and then applying the function. That's going to reflect about the y-axis. Now, if your function is symmetric about the y-axis, you're not going to see a reflection then, because it's just going to look the same. But we have some examples where you'll be able to see the reflections. So, reflects about the y-axis, okay? So it makes a difference where your opposite sign is, if it's before you apply the function or after you apply the function. So, and in the top one that I have, you're applying the function first, then you're taking the opposite. That affects the outputs. But in the other one, you're taking the opposite of the input, and then you're applying the function. Okay, well, I hope that makes sense, but maybe some examples will help. So my parenthesis didn't print very well here. So here's f of x. And what I'm going to do to try to make this the easiest way for you to graph it, well, we'll do it two ways. So let's look at this point that we have on the far left there. That point is -7, 2. It's the same function we've been using, so we've seen it before. But now, if this is going to reflect about, well, I can't spell reflect. I just put, it reflects about the y-axis, okay? So we were at -7, 2. Now we're going to be at +7, 2. So we're going to get a point, I'm going to do it in a different color, right there, okay? So it's just like you folded your piece of paper on the y-axis, and the point that was over there at -7, 2 is now at +7, 2. Now why is that? Well, we can say if f, we can say if f of x has a point -7, 2, then when I plug in, to get a -7, I have to plug into g of x. So let me go over here. G of x, I have to plug in a +7, because then g of x is equal to f of the opposite of x, right? So when I put in a 7 for x, a +7 for x, I'm doing the opposite of 7, which is -7, and now I know that f of -7 is 2. So I get that point there, okay? And we could do that for all the points. And we might want to. I did that on one of the, on the worksheet for this. I wrote out all the ordered pairs for you. Okay. All right, but let's look at the transformation. So here we have a point that's at -4, 6, I think, and so it's going to go to +4, 6. So it's going to be like right there. Yeah. All right, this point that's at 0, -3, it's going to stay at 0, -3. If you plug in 0, the opposite of 0 is still going to be 0. Your output's going to be -3. All right, now we're looking at the top of the mound there, I guess, the hill. It's at -3, 0. So now it's going to, I'm sorry, it's at 3, 0. Now it's going to be at -3, 0. So it's going to reflect about the y-axis over there. And then finally, we have a point at, looks like 6, -3, so it's going to go to -6, -3. So it'll look like that. Now, drawing this, we've got to make sure we get our little hill, the little curved part, kind of. And then these others are going to be straight. Well, straight as I can draw. Okay. That should look like if you folded along the y-axis that the blue points would line up on top of the black points for that graph. So it's kind of cool. But anyway, that's g of x. All right, let's do another example. Okay, this one's different because the opposite sign is in front of the function. So this is going to reflect about the x-axis. And these are a little bit easier to do. We're kind of used to these with parabolas because we've probably worked with more parabolas. But the same thing is going to happen. Our outputs are going to change now. So the point that I used to have at -2, 4 is now going to be -2, -4. And you can think about plugging in, if g of x is equal to the opposite of f of -2, we know what we know the output at -2. That graph is given to us. I didn't label it, but this is my f of x right here, right? Okay. So when I put in a -2 for x, I'm getting out a +4. But now I'm going to get the opposite of that +4, which is -4. So that's why we get an input of -2, but an output of -4. Okay, so then this is going to reflect to here. 0, 0 is going to stay the same. This one's going to, and sometimes we say, well, the parabola, flipped upside down. It did. Now, there's no rhyme or reason why I did which one. Example 7 was a reflection about the x-axis, and example 6 was a reflection about the y-axis. You could have either one. So